So here's the final regulation on the 2-bore here, and obviously you can see the sights are still a little off, but that's just a matter of adjusting the sights and getting them down to where they need to be. But what I wanted to show you is center to center on these is about 1 7/8 inches, which is slightly narrower than the bore lines. The bore lines at the muzzle, center line of the bore at the muzzles is 2 inches center to center. So this thing's actually converging just a little bit. But since this is a 2-bore and it's at 50 yards, a little bit of conversion isn't going to hurt this thing, because you're not going to shoot this thing out to 300 yards anyways. And even at 300, with that little bit of convergence, it would still be well within hunting accuracy. So it's really pretty good regulation. You can see that you know, judging at the line, it's about 1/4 inch off of horizon, which is really acceptable. That's a really close grouping to be that close off the horizon line, and then to be nearly parallel with the bore line. You know, 1/8 of an inch slight convergence isn't really a problem. You know, if this was a smaller caliber, I'd probably adjust it a little bit and bring it back out to parallel, or maybe just a little bit over parallel. But for this here, this is a very acceptable group. I did do some velocity work and run it across the chronograph and whatnot. This is with the 500 grain SxS GoX charge. It's a wool felt column, Winchester 209 primer in the S&H brass, and then it's getting about 1,300 feet a second, about 20 foot ahead of the muzzle. This is where my chronograph was set. So 1,300 foot a second on a half pound round ball is really pretty phenomenal, actually. You know, these things really don't generate a ton of speed. One, because they're black powder, and two, because of the mash you got to push through them. So 1,300 is really moving along at a pretty good clip. So. But anyways, that's the final regulation on this, and this target with the load well at work and everything will go with it, and when it's delivered to the customer. So I'm pretty happy with it. But it did take me about 3 weeks to do it, and usually I can regulate a gun in a day or two at the most in normal calibers. The reason this one took me 3 weeks to do is because, you know, it was go out and shoot it, and then I had to wait about 3 days. You know, I could shoot it and take it back in the shop and heat it up like I showed you and make an adjustment. Then I really kind of had to wait about 3 or 4 days in between, because my shoulder was pretty tender. And so it took a long time to regulate this, not because of the number of shots or the you know, any problem I had with regulation, but because it just has so much recoil that I couldn't go out and shoot it repetitively or a lot of shots in a single day. So pretty long process for this gun. I didn't waste the time in between, though. I did have a couple other projects that are for the same customer, and so I worked on those on the days in between and got most of his other projects finished up. So that'll be all of his stuff will be ready to go when this thing's finished. The amount of powder I used between the load development work I did and the regulation work, I went through about 3.5, maybe 4 pounds of powder. So pretty expensive gun to shoot, and quite a bit of you know, powder used in regulation. But that's where we're at on that. So now I can move on to doing the last of the finish work and get this gun finished up. So before I can start cleaning all this up and finishing this project up, there's one more little thing needs to be done here. As you can see, there's still some of the regulation wedge sticking out. That's going to have to be trimmed off and then polished flush. But there's also, you'll notice, a big hole here, and that's the gap between the rib and the valley and the barrels. And there's a couple little lines here where the front sight is, and a little gap underneath between the sight and the wedge. And those spots all have to be filled in. For this big spot here, of course, I'll cut a piece of metal, fit it in there, and you know, take up most of the space with a piece of metal in there. And it's just going to be a little thin piece of you know, 1/8 inch or thinner material, so it's not going to make the weight or anything change. It's just going to fill in the gap. But the type of solder I'm going to use for this, you know, originally I mentioned that I use typically 2 different types of solder to do the regulation and wedges and stuff, and I usually use high force 44, the high temp and the low temp, to do this. And one of the reasons I do that is because this last little finished bit here, now that regulation is done, I don't want anything to screw this up. And so the last thing I do when I fill this in and solder these in is I use a Cornish tin. That's kind of the old name for it, is Cornish tin. The modern version of it is called Tix, T-I-X. And Tix is a solder that doesn't have it's not got a lot of holding strength, and it doesn't do a lot of fill work very good. But it has a very low flow temperature, just like the original Cornish tin was. Flows at like 275 degrees. So 200 degrees below even the low temp high force 44, which means I can solder these parts in here and not have to worry about anything changing or moving, because I'm not going to get it warm enough to loosen up any of the other solder. So that's what I'm going to do, is I'll cut this off and I'll fit a piece in here and get all the joints filled in with solder in the front here, and then I can start working on cleaning up the rest of the barrel and everything. When it comes to cleaning this up, it's really not a complicated job. It does take a little care and precision to do it, but it's pretty basic work. And the tools that I use are this is just a cheap set of chisels here, and got them out of a bargain bin a long time ago. And I got a couple different shapes, obviously, but they're all basically flats with just some different profiles to them. And the reason I use cheap chisels to do this is because I'm going to be chiseling the bulk of the solder out of the joints. I don't want to tear up my good woodworking chisels, and so cheap set of chisels that you know you're going to run up against metal and ding the edges and stuff, they work just fine for chiseling the bulk of the solder out. And solder is soft enough that you know, even a cheap chisel is usually hardened enough to cut through the solder. Usually I knock the corners off of these. I kind of want the corners just a little dull on them. And the reason is because I don't want the corners to gouge into the steel of the barrels or the ribs and all. So I usually knock the corners off, and they're not very sharp. They're really just designed to act more like a scraper than they are a chisel. So I use some chisels to get rid of the bulk of it. To get down inside of the really tight part where the rib comes in close to the barrel, I've got some real fine rifflers that come down to some real fine points. That helps get down in there and remove some of the solder. And then the other tool that I do is I usually make my own, and these are this is just a piece of 3/32 tool steel or drill rod, and I grind them or file them or flatten them to whatever shape I need to get down inside of there, and then I just heat treat them and use them as is. And they're a real good tool to, you know, you can shape them any way you want, and tool steel is pretty easy to deal with for heat treating and stuff. So I make the rest of the tools to get down in and scrape the real bottoms of the joints out. So the other thing you can do is, if you don't want to make your tools, you can buy dental picks. You know, just like the dentist uses. They're made out of good quality stainless, and they come in all different shapes and contours and stuff. And so dental picks work really good too, but they can be a little pricey as compared to tool steel. And with tool steel, you can shape it however you need to, instead of dealing with whatever shape the dental pick comes in. As you can see, there's quite a bit of solder on these joints here, and that's a pretty good amount to take out. It's got to all be taken down to where the solder completely disappears. And so I got to, you know, start by chiseling the bulk of it out, and then I'll come back in and start scraping it out. And then, of course, once all the solder is scraped out, I'll go ahead and sand the barrel down to its final finish. But one of the things about high force, using high force 44 is unlike a lot of other solders, the contents in high force 44 will not blue. There is no product on the market that will make them turn black. You can get them to turn kind of a darker gray, but I've never found anything that actually turns its high force completely black. So this stuff really all has to be completely off the metal, or it will be seen. And one of the ways to check that when you're sanding this and cleaning it all up and getting all this solder out of here, one of the ways to check and make sure that you've got it off the barrel, especially in spots like like here where it's got just a little ribbon of solder sticking on the rib or whatever, or a little bit sticking up. One of the ways to check and make sure you've got it all completely cleaned off of there is to use a little bit of cold blue. I just typically use Oxbow blue, and you just rub a little cold blue on there, and of course the metal will turn blackish, and the solder won't. So it's a real easy way to check when you're cleaning this up as you're going along. to make sure you're getting it all completely cleaned up so it'll blue up nicely, is to run a little cold blue on there, and wherever the silver shows up from the cold blue, you got to keep working at it until it all disappears. So that's the process, and I'll start by getting those muzzles cleaned up and finished off, and we'll go from there. So the other thing I did this week is start to do the finish on the wood, and it doesn't take very long to do this, and I can do it every morning and then work on the barrel stuff and cleaning that up in between, because mostly it's just drying time. But this is the first couple coats of stain. The stain that the customer chose is kind of unique. It's called Antique Red Oak, and you can see that it's kind of a gray color. You can see the contrast between the natural maple that's under there and then the stain color. It's called Antique Red Oak though, and it kind of comes out this gray color with some real nice red highlights. This is the first time I've ever actually used this stain as an actual stain color. Usually the way I use it is I usually apply it a coat or two, I wipe it off, let it dry, and then I usually go over the top of it with a darker stain, usually like a walnut stain or honey maple or something like that. And what it does is it just gives me those really nice red undertones, and then you get a nicer, darker stain color. But the customer looked at the samples I sent him. He really decided this is what he wanted, and so this is the color it's going to be. It's going to be that kind of gray color with the nice red tones to it. You can see this stock is really a plain stock. But the reason that wood was chosen, like I said a long time ago in the videos, was it wasn't chosen for its figure or character. It was chosen for its grain structure and its density. So not a lot of real classy figure in that stock, but it's definitely a heavy grain stock that's going to really hold up well. And it's going to be an interesting color. I'm really kind of anxious to see how it turns out. But got to let this dry, and then every morning I'll start working on hand rubbing a coat of finish into it as it dries. Right now our humidity is running kind of low, so it should dry fairly well. Some of the finish times I've had in the summertime when our humidity is really high around here, it can take 3 or 4 days in between coats. But right now I should be able to do a coat a day on this. So as I'm doing that, I'll get a coat a day on this first thing every morning if it's dry enough to do that, and it'll be a hand rub coat every single time. And then the rest of the day I'll work on the barrels and polishing that stuff up and doing the finish stuff. But once that's all, the finish is all on the wood, then I'll be able to come back and checker it, and the stock will be finished. So that's what it's going to look like basically. That pretty much wraps it up for the week. I'll jump back on this stuff Monday and get it all finished up. Hopefully by the end of next week I'll have all the metal all polished back up and the engraving on the metal done and be able to rust blue those parts. And like I said, the finish on the stock, that's going to take however long it takes to dry in between coats. Hopefully I can do 1 coat a day, but we're expecting some snow and stuff starting next week, so humidity is probably going to climb up around here a little bit, and it may take a couple days in between coats with the humidity going up. So we'll just see how it goes. But I'm really hoping to have this project all wrapped up by Christmas or the end of the year, somewhere right in that time frame, and it'll be ready to go to the customer by then.